Hi, I'm Brandon Weiss, co-founder and chief innovation officer for Dvele, and we're a modular home company focusing on high performance, healthy, self-powered, and modern design homes. So we're in beautiful Lake City, Colorado. We're on the banks here of the cliff above the Lake Fork River. Beautiful spot, beautiful lot for a Transcend demo home. So this home is a prototype home that we're going to be using as a showcase to show kind of a shift in our business philosophy from a direct-to-consumer to business-to-business, so looking at a developer model. And this will be kind of one of the home types that we can offer through that. Transcend Communities is going to be, like I said, 20, 30 or more unit communities that are focused on the same kind of things that Dvele holds near and dear with regards to sustainability, energy independence, and healthy homes. And so this home is overlooking this beautiful view around me, and we're right now currently installing our first prototype foundation system. So this is the first time we've actually prefabricated our foundation system. We've done that for several reasons. One is the speed. It used to take us a couple weeks to get our foundations in on site, would require partnerships with local contractors. Right now we had the footings prepared before we got here, and now we'll have these walls, and the first one here probably 2 days, but after that it'll be about 1 day to set our foundations, which saves a significant amount of time, significant amount of money, as well as reduces our embodied energy. So the embodied energy reduction in this versus a code-built foundation system is about 80% less global warming potential and 20% less than what we used to do on our previous version 1.0 wall, which was an ICF wall. So living up to the standards of, we've always been focused on the operational energy and been aware and trying to reduce our embodied energy. Now we're actually modeling it and taking steps with which to mitigate and reduce that additional carbon footprint of our homes. So this is a light gauge steel structural wall. And on the outside of that, we have a magnesium oxide panel that gives it the structure and the shear that is mechanically fastened both the wall together as well as to that sheathing on the outside. And then all the screw heads as well as all the joints in that material are sealed with a liquid applied membrane. And then the whole outside coating comes back, and there's another liquid applied coating that goes on that. And that all gets protected by what's not on it yet because we have to get it set first, will be exterior insulation. So this house is going to have 7.5 inches of exterior rock wool insulation on the exterior of it, followed by a gap drainage membrane that'll be the primary weather barrier and drainage membrane between the earth and the foundation system and the insulation. So the insulation will also stay dry. Steel does have a higher embodied energy than, for example, FSC certified wood, but we're not going to build a foundation system out of wood, nor would it be perfect and be scalable for a business model. With us doing this, we can actually prefabricate these at our facilities, send them to site, and they come in knockdown panels. We can assemble really quickly, and there's really no plumbing and things like that in it, so it's not slowing us up. Whereas like our modulars, we don't build panelized, we build modular because we can fit all that mechanicals within it. Everything's like pretty much 90% complete in the factory, and then 1 day of actual set time once we get this up and running. Now steel, it does have a high embodied energy compared to a lot of other products as well, but when you're comparing like structural products like this, really we're comparing concrete versus steel. And concrete has a higher embodied energy than steel. And plus the cubic footage or cubic yardage of that concrete versus the actual amount of tons of steel. We're just using a lot less carbon intensive materials through that process, and we are using a recycled steel as well to further reduce that. And looking at a couple upcoming products that are coming on the line that aren't to market yet, but eventually we'll get to carbon zero steel, which will even further improve our delta between concrete and steel. The MGO board actually absorbs carbon dioxide as it's curing through its manufacturing process, so carbon negative material, which is great, and has all the same shear values and things like that as a plywood would, so we're gaining the structural value. It's also impervious to insects. It also is vapor open, so it allows vapor to flow through it, which in a crawl space like this will be a great advantage. The rock wall on the outside is also vapor open, so we have some diffusion properties to this wall that'll be pretty great. Another advantage of this wall is that it's mold, mildew resistant, so mold can't grow on it. It's waterproof, and if it does get wet, water can sit within the product, but it dries out really rapidly. And because the whole assembly is diffusion open, it has that drying potential. But we have taken a lot of precautions to keep it dry from both directions here, and as well as from below once we put the insulation and the vapor barrier, which you see the yellow around here. Once that's taped seams, that'll give complete vapor protection from subslab and soil gases as well. So the next step, we'll get all these walls up, we'll get them braced together, we'll remove these so we can do that subslab work before the modules arrive. The modules will come, land on top of the structure, and get fastened with mechanical fasteners and hold downs. We'll be ready to make those cross connections and to really showcase this really innovative prototype home that we hope to build hundreds and thousands of across the country in the coming years.